Okay, so we're going to talk about exponents today, and you hopefully have looked at the PDF that I've included. There's a handout. I got to backtrack on my notes here, but we're going to go through all those properties and we're going to add some stuff to it. Um, I put more on that PDF than I usually do, but I think it's helpful for you guys to write down as well. So have that either you're looking at it or you're writing some of this down. We're going to talk about the properties of exponents. So the properties of exponents, we have product of powers. Product of powers, we're multiplying two things. The bases are the same. This is the base, this is the exponent, so the bases are the same. When the bases are the same, you add the exponent. So in the little note section, whoops, started to write notes. In the note sections, we're going to say you add the exponents, but let's also put you have to have the same base. So those are just some reminders to us that we're putting there. And then once we have that, then let's put an example. We're going to see a lot of numbers today. We'll also start to see variables. People tend to think that's easier, so my examples are mostly going to have numbers for this handout. Let's say we have 3 squared times 3 to the third. What you have to be careful with here is it's the same base, you keep the base. So you don't multiply those, you keep that base, then we're gonna add the exponents. You don't have to show me that you're gonna do 2 plus 3, just go ahead and add those. And then anytime we have an expression like this at the very end, we're gonna get that in our calculator. So in your calculator, remember you're gonna do 3 and then that caret button, that exponent button 5. And when we do that, we're going to get 243. Good news here with all these properties, I forgot to mention it, is you do not have to memorize the name. I'm not going to ask you that next year when we go over these. I'm not going to ask you that. We just have to know how to use these properties. Next one, power of a power. So this one, what I kind of think of it as is I'm taking this exponent to that one. Another way that's going to tie into this next property is we're going to say is that we distribute, but what's important is we distribute exponent to exponent. And remember, when we distribute, what are we doing? Oh, we're going to multiply. So that's going in that notes section. For an example, let's again use something with numbers. Let's say we have 4 squared, and I don't know, let's say that's to the fourth. We're going to get some big numbers here. So we're going to distribute exponent to exponent. I keep the base. 2 times 4 is 8. So then we go to our calculator and we put in 4 to the 8th. This is a step I'm looking for because, yes, you could put that in your calculator and get this answer, 65,536. But I'm looking for you to use that property. A lot of these, especially in the beginning, are just going to be 1, maybe 2 steps, but they'll start to get more complicated as the assignments go on here. The next one we'll look at ties to the same thing, except we're going to distribute to all the exponents. And if something doesn't have an exponent, it has an exponent of 1. So I distribute to both of those. So distribute, I'm going to put to all exponents. And again, when we distribute, we multiply. This one, you're not going to see all numbers. We might have something like 3x squared, and let's say that's all to the third. Well, that 3 has an exponent of 1, so I distribute to both exponents. I don't multiply 3 times 3, I multiply 3 times 1, so it's 3 to the third. And then I multiply those two exponents, so x to the 6th. This part I can go ahead and multiply out then. 3 to the third is 27, and then we're going to keep that x to the 6th. Negative exponents. There's a couple ways we can think about negative exponents. If I have a negative exponent, then what I do is I draw a fraction line and I put an arrow. Now I'm not just moving that exponent, as you can see what it's equal to, I'm moving the entire thing. But what happens when it's on the bottom? Well, if it's on the bottom, you're already going to see the fraction, and you just have to think, okay, I move it up. The moving of that up or down changes the exponent to positive. So let's put move up, down, and let's put changes exponent to positive. So we'll have two examples here. Let's say we have 3 to the negative second. I'm going to put a fraction bar, drop it down. So that means I have 3 squared on the bottom. Well, if it's on the bottom, I have to have something up there, so I'll put a 1. And then I would go ahead and multiply out that 3 squared. That would give me 1/9. Fractions, fractions, fractions. I do not want to see any decimals here. And let's say we have something on the bottom. So let's say we have, let's use an x this time, x to the negative fourth. Well, I'm going to move that up. I could keep the 1. I don't have to. There would be a 1 underneath, but when it's underneath, we don't need it. Most people are going to write just x to the fourth, but 1x to the fourth would be okay as well. Zero exponent. Zero exponent is easy. Anything to the 0 power is 1. So anything to 0 equals 1. What it gets confused with is people say it's equal to 0. So just got to get that memorized. So if I have something like 349, something crazy to the 0 power, I hopefully don't think about it. I just say, oh yeah, that's 1. Quotient of powers. Well, what we're doing here, notice same base, we're subtracting. So let's put same base, and we're going to subtract. Now there's a little trick to this one that I like to use. And so what I like to do is I like to do big number minus small number, because that's how we subtract. And then our answer goes where the big number was. Now that's a lot, but it has to do with those negative exponents. So when I look at my examples, let me first do off to the side here a little example without that, just subtracting. So let's say we have x to the fifth over x squared. Well, I subtract 5 minus 2, that's 3. Well, 5's on the top, so x to the third goes on the top. Nothing's on the bottom. I've been combining those x's. Well, let's say it's on the bottom. If I have x squared over x to the fourth, then when I subtract, if I just straight subtract like this property says, I'm going to have x to the negative second. Oh, but then I have to move it down. So the shortcut I'm using here is I'm saying, okay, I'm not going to do this part. I'm going to say 4 minus 2, because that's how I like to subtract. But since 4 is bigger, my answer goes on the bottom. So let's put our real examples down. Let's say we have x to the third over x to the ninth. Think about where our answer is going to go. 9's bigger, so the answer is going to go on the bottom. 9 minus 3 is 6. And since it's on the bottom, I need something on the top. But if I have something like x to the fourth over x, this is another good little reminder. Remember, that would have an exponent of 1. I do 4 minus 1 is 3. It's going to go on the top. You can put a 1 underneath all that. You don't have to. All right, almost done with our properties here. We're going to go ahead and distribute to each of those just like before. So distribute, still exponent to exponent, but you have to do top and bottom of the fraction. So there's an exponent of 1, I distribute to each of those. So if I have something like 3 over 5 squared, that has an exponent, that has an exponent, becomes 3 squared over 5 squared. And we've actually kind of talked about that. Think back to completing the square. We square the top, we square the bottom. 9 over 25. Final answer on that one. Okay, I think what I'm going to do here is I'm going to end this video. That way, if you want to go back to it, it's a little bit shorter video to go back to, and then come back and look for the first set of examples for the next video.